Okay, so we spent the last 3 days solving system of equations by graphing by hand. So yes, we've tortured you enough, but we are going to show you a calculator way to do this. Okay, but it is important you know how to graph, especially when we go into the next unit, so that's why we do cover it so thoroughly. So here's how we do it in the calculator. Is first, we still have to convert to slope-intercept form. That's always a given. And then we're going to type into each equation into the calculator and tell the calculator to find that intersection for me. Okay, so I'm just going to jump right into it. This first example right here is just a little preview. So they already have it in slope-intercept form. So what you do in your calculator is you go to y equals, and we are going to type both equations in. In y1, I'm going to type in 3x plus 2. In y2, I'm going to type in x plus 4. Then I'm going to hit graph. What you need to be able to see within this window is both lines and where they intersect. Since I can see both and I can see where they intersect, we're going to tell the calculator, hit a 5-button combination of what that coordinate is. So we're going to hit, and it's on these notes, second trace 5, enter, enter, enter. And we've told the calculator to find the intersection. And if you look at the calculator, it tells you at the bottom of the screen, the coordinate of that intersection is 1, 5. So there's my answer. Okay, so if I look at this first example, we first have to convert both to slope-intercept form, so that's always a given. So in this first one, I'm going to subtract 3x, so 2y equals negative 3x minus 8. I'm going to divide everything by 2, so y equals negative 3 over 2x. Negative 8 divided by 2 is negative 4. The second equation, I'm going to subtract x first, so I have negative y equals negative x minus 1. Divide everything by negative 1 to get y by itself, so negative x becomes positive x, and negative 1 becomes positive 1. Make sure you do this correctly, because when I type it in my calculator, it won't be correct unless I have my equations converted correctly. So this first equation is going to be negative 3 over 2x minus 4. The second equation is going to be x plus 1. Then I hit graph, sorry. I let it load, give your calculator a chance to load. So you should see 2 lines and where they intersect. If I can see that, then I'm going to do second trace 5, enter, enter, enter. And we have the word intersection at the bottom of our screen, and there's our coordinate. My x and my y value is negative 2, negative 1, and that's my solution. Okay, so if we continue to practice this, always make sure it's in slope-intercept form. So number 1 is, so we're just going to type it in my calculator. So we have x minus 8 and negative 2x plus 1. You hit graph. So there's my graph, there's one graph, there's the other. I do see where they intersect, so once it's done loading, I do second trace 5, enter, enter, enter. My intersection is down at the bottom. It says 3, negative 5, and there's my solution. Number 2 is already in slope-intercept form, so we go ahead and graph it. 1 over 2x plus 9 is negative x plus 6. Okay, there's my blue line. Here comes my red, and I do see where they intersect, so I do second trace 5, and second trace 5, enter, enter, enter. Says the word intersection. My intersection point is negative 2, positive 8, okay? Number 3 is not in slope-intercept form for both, so I do have to convert both, okay? So on the first one, I have to add 3x to both sides, so I have y equals 3x plus 8. On the second one, I have to add x to both sides, so y equals x minus 2. Once I have both in slope-intercept form, I go to graph, 3x plus 8, and then x minus 2. Graph, let it load, there's the blue line. There's the red line. I do see where they intersect, so second trace 5, enter, enter, enter. My point of intersection is negative 5, negative 7. Okay, on number 4, I have one of them set in slope-intercept form, but the other is not. So the first thing I need to do is subtract x. So I have 2y equals negative x plus 4. Divide by 2. So y equals negative 1 over 2 is negative 1 over 2x. And 4 over 2 is positive 2. Okay. Now, I know you could already see what's going to happen because we've been practicing it for the last 3 days, but I do want to show you what it looks like on my calculator. So if I type in both equations, the first one we converted was negative 1 over 2x plus 2. The second one is the same, negative 1 over 2x. Oops, I don't know what happened there. Plus 2. So yes, in my mind, I know that they are exactly the same equation, which means they're going to be exactly the same line. But I want to show you what this looks like on my calculator. So if I hit graph and watch carefully, just watch carefully. So if you look, there's the blue line loading. And then if you look, there's the red one. If you notice what it's doing, it is literally covering up the blue. That means they are overlapping, which means this is one of those examples of infinite solutions or all reals, okay? Because they are the same exact line. Now, number 5, one's already in y equals, the other one is not, so I do have to subtract x. So I get 3y equals negative x minus 15. Divide by 3. So y equals negative 1 over 3x minus 5. If I graph both equations on my calculator, I have the first one was negative 1 over 3x minus 5. The second one was just negative 7. If I hit graph, let it load, there's my blue line. There's the second. It's just a horizontal line. Then I do second, trace 5, enter, enter, enter. My point of intersection is 6, negative 7. Number 6, the first one's in slope-intercept form, but the second one is not. So we're going to subtract x. So I have negative y equals negative x plus 2. Divide everything by negative 1. So y equals 1x minus 2. Then we graph both on my calculator. So the first one was x plus 5. And the second one we said was 1x minus 2, or just x minus 2. Hit graph. Okay, so this is the second type, special type, I guess. If you notice, they are parallel. And if you're not sure, you can zoom out. So we haven't had to do this yet, but if they really look parallel because they're going the same line, it doesn't look like it's squeezing on one side, then that means we have to keep going to see our intersection. So since this is parallel, this would be no solution. Okay, number 7, they're both in standard form, so we have to convert both. The first one, we're going to subtract 3x, so I have negative 5y equals negative 3x minus 35. Divide by negative 5 to both sides on everything, so y equals 3 over 5x. Negative 35 over negative 5 is positive 7. The second one, we are going to subtract 2x, so y equals negative 2x minus 6. Once we've converted both, we type them into our graph or equation. Oof. Okay, the second one, negative 2x minus 6. There's the first one. There's the second. So then we do second trace 5, enter, enter, enter. My point of intersection is negative 5, 4. Okay, now the only time I cannot use my calculator, okay, for the intersection is on number 8, because the first equation is x equals, okay? The graph, if you notice when I hit y equals, all of them are y equals. There is no way to change it to x equals. So this is where you have to use the actual graphing paper on this one. Because x equals negative 2 means it crosses the x-axis at negative 2, and it's going to be a vertical line, okay? Now the second equation I can graph, but I can't find my point of intersection on my calculator, so I have to graph it by hand. So we convert to slope-intercept form by subtracting 3x. So I have negative 2y equals negative 3x minus 18. Divide everything by negative 2. So y equals positive 3 over 2x plus 9. So when I graph, I start at positive 9. And I'm going to go up 3, right 2. Or if I can't, I go down 3, left 2. And notice that is where they intersect. But if I keep going, just to finish my line. Oops. Okay. They do intersect at this point, and that coordinate, if I start at the origin, is negative 2, 1, 2, 3, 4, 5, 6. Negative 2, positive 6. Okay, now if, I know I've been saying every question like, oh, okay, I can see the intersection in the graph. But if you cannot see the intersection in each graph, okay, you have options, but I just tell my kids zoom out. So you have this zoom button, okay, and then zoom out is option 3. And then you hit enter, and it literally zooms out slightly, okay, to where you could get a better idea if the intersection was not in the window. So you'd have to zoom out if you don't see where they intersect. It doesn't happen very often, but it's a good tip to know.